Everyone is obsessing over the model to hitting a $25,000 sticker. But that's not actually the story Tesla is telling if you look closely at what's happening behind the scenes. The real signals aren't on the price tag at all. Giga, Texas, quietly doubled its footprint. Elon said during the Q3 call that he feels confident expanding production capacity. Mint, China, Model Y just received premium upgrades as standard equipment instead of paid options. None of that lines up with a company bracing for margin pressure. It lines up with a company preparing to shift how people think about long-term vehicle ownership. Here's the part that almost no one is framing correctly. Tesla isn't trying to sell a cheap car. They're trying to delete the $40,000, $50,000. People unknowingly burn over 10 years on fuel, maintenance, repairs, and downtime. And if they succeed, the consequences won't just hit new car sales. It will ripple straight through the used car market sitting in driveways right now. Let's start with the battery, because that's where most of the confusion begins. Rumors point to a 53 to 55 kilowatt pack for Model 2, compared to a Model Y's roughly 75 kilowatt hours. That sounds like a downgrade on paper. Industry headlines immediately label it a compromise. But that framing assumes range is the primary cost driver. Over a vehicle's life, it isn't. At roughly $130 per kilowatt in raw battery cost, that 20 kilowatt hours difference represents about $2,600 in materials up front. Over a 10-year ownership window, that gap quietly expands into something far larger. Bigger packs carry more replacement risk, more thermal stress, and higher insurance exposure. When you factor all of that in, the real long-term delta lands closer to $7,000 or $8,000. Tesla isn't shrinking the battery to cheapen the car, removing the single biggest financial landmine most EV owners face after year 6. At current replacement costs, a Model 3 battery swap today runs roughly $12,000 to $14,500. A Model Y is even worse, ranging from about $15,500 to $18,500. Those numbers don't show up on spec sheets, but they live in the back of every long-term ownership calculation, whether buyers consciously acknowledge them or not. Now ask a more honest question. Would you'd rather have 350 miles of range that you realistically use a handful of times per year? Or would you rather reduce your worst-case 10-year financial exposure by $8,000? The average American drives about 37 miles per day. A 250-mile real-world range covers nearly a full work week without plugging in. For most people, anything beyond that is psychological comfort, not functional necessity. That smaller battery also triggers a cascading set of benefits that rarely get discussed. A 55 kilowatt-hours pack in a lighter vehicle changes everything downstream. Rumors suggest Model 2 could weigh somewhere between 3,300 and 3,800 pounds, compared to over 4,000 pounds for larger Teslas. That difference matters. Heavy EVs chew through tires 20 to 30% faster because instant torque is acting on more mass. Over 10 years at 12,000 miles annually, that alone translates to roughly $1,200 to $1,800 saved on tires. Insurance is another hidden drain. Insurers currently price EV policies $400 to $800 higher per year than comparable gas cars. Largely because repair severity spikes when battery damage enters a claim. A lighter, simpler EV with a smaller pack lowers both repair costs and total loss risk. IFE Model 2 pushes insurance premiums back toward traditional gas car levels. That's another $4,000 to $8,000 saved over a decade. This is where Tesla's strategy flips the traditional auto industry playbook on its head. For decades, manufacturers competed by piling on features, power, and complexity. Tesla is betting that buyers are finally ready to value predictability over bragging rights. That philosophy becomes even clearer when you look at manufacturing. Model Y already eliminated around 172 parts in roughly 1,600 weld points through Giga casting. Model 2 pushes that logic even further. Every weld is a stress concentration. Every joint is a tolerance stack that slowly drifts over years of load cycles. When suspension mounting points shift by even half a degree over time, the symptoms start creeping in: steering pull, uneven tire wear, vibrations, and that vague sense that the car just doesn't feel right anymore. What happens next is familiar to anyone who's owned a car past year 5. You pay $75 to $175 for an alignment. 6 months later, the tires start wearing unevenly again. You blame the shop, but the real problem isn't the alignment. Structural drift. Dozens of stamped panels welded together are slowly relaxing under stress, and no amount of adjustment can permanently fix that. Model 2 consolidates what used to be dozens of separate pieces into maybe 5 to 7 large castings. Research shows that just 1 degree of toe misalignment can increase rolling resistance by over 25%. If Model 2's structure drifts even half as much as a traditional build over 10 years, you've eliminated 3 or 4 alignments outright and extended tire life by 15 to 20%. That's another $500 to $900 you never spend. More importantly, it's time you never lose sitting in a waiting room. Trying to describe a vibration the mechanic can't reproduce. The same thinking shows up in vibration engineering. Low frequency. Vibrations between roughly 20 and 200 Hz overlap with road inputs and drivetrain pulses. Studies from lean manufacturing and suspension engineering consistently show that every weld introduces a stiffness, discontinuity, where vibration energy concentrates. Remove 1,600 welds, and you remove 1,600 future rattle points. Anyone who's owned a 7-year-old car knows this pain. You take it in for a rattle you can't quite describe. Technician spends 2 hours at $120 an hour chasing it down. Replace a clip or add foam. The noise goes away till 3 months later. That's not bad service. That's a structural vibration problem baked into the design from day one. Model 2 attacks this at the root. You're not paying for silence when the car is new. You're paying for silence when it's old. This structural discipline carries straight into electrical architecture. Industry data shows that between 30 and 60% of vehicle electrical faults originate in connectors and terminals. Every connector is exposed to microvibration, thermal cycling, and humidity over millions of cycles. Contacts oxidize. Signals become intermittent. Intermittent faults are the most expensive kind because technicians can't reliably reproduce them. Diagnosis often turns into trilateral modules swapping at $100 to $150 per hour. $12 corroded connector quietly becomes a $600 bill. Model 2's minimalist electrical design reduces module count, shortens wire runs, and increases integration. If Tesla cuts connector count by 30% and connectors account for roughly 40% of electrical issues, that alone eliminates about 12% of all future electrical problems through design. Over 10 years, that likely prevents 2 or 3 shop visits at $400 to $800 each. Again, this isn't flashy. It's just quietly removing failure modes before they ever appear. Performance targets follow the same philosophy, rumors suggest. 0 to 60 times in the 6 to 7 second range, not 3 to 4. Single motor, not dual. From a durability standpoint, this matters far more than people realize. Systems operating near their design limits age faster. Motor heat loss scales with the square of current draw. Running a motor at 70 to 80% of its peak capacity instead of 95 to 100% can cut heat generation by 30 to 40%. Less heat means less thermal stress on windings, magnets, bearings, and seals. You're not really giving up speed you use day to day. You're gaining longevity in components you never think about until they fail. Battery management benefits. The same way, lithium-ion cells degrade fastest when high state of charge, high temperature, and high current draw overlap. Model 2 is designed to live outside that danger zone. Instead of degrading at 2 to 3% per year, the pack may degrade closer to 1 to 1.5% annually. After 10 years, that's the difference between 85 to 90% remaining capacity and 70 to 75%. That gap is enormous. One battery still feels normal. The other starts creeping toward replacement territory. Tesla doesn't market this. because it doesn't sound exciting. But talk to any EV owner past year 6, and this becomes the only thing that matters. When you connect all of these dots, you see why Model 2 isn't really competing with new gas cars at all. It's making 5 to 7-year-old gas cars look like risky bets. Take a 2020 Toyota Camry listed at $18,000. Today, it feels safe. Proven reliability. Predictable depreciation. You expect to drive it 5 years and sell it for maybe $13,000? That math works right now. But once Model 2 establishes itself, buyers start asking different questions. Do I want 5 more years of gas, oil changes, brake work, transmission uncertainty, and rising fuel prices? Or do I want a vehicle engineered from day one to minimize everything that usually goes wrong between years 5 and 10? That's when the used car value equation starts to crack. Tesla isn't shouting about this because it doesn't fit into a spec sheet comparison. But structurally, electrically, thermally, and financially, Model 2 is designed to age better than almost anything in its price class. Not flashier, not faster, just calmer, cheaper, and more predictable over time. If this strategy works, the shock won't be that Tesla sold a $25,000 EV. The shock will be realizing how many safe used cars suddenly aren't such a good deal anymore.